Hi, Mr. Pang. Hi, Mr. Pang. Today I'll presenting the system I created. Here we have the main components: the Arduino Uno R3, the PIR sensor, the ultrasonic distance sensor, the micro servo motor, a buzzer, a potentiometer, LCD screens, and two LEDs. So let's look into the codes. So in this part of the codes, I'm setting up the initial configurations for the smart dustbin systems. So it begins. So we look at the void setup. It begins by initializing the serial communication at the baud rate of 9600. So it allows us to communicate with our Arduino boards for debugging purpose. So next, the LCDs display is initialized with a dimension of 16 times 2, printing the starting message smart dustbin. And the servo motor is attached to pin 11, prepare it for control. So following this, the pins for the ultrasonic sensor is configured. As you can see here, the tri pin is as output, the echo pin as input. And set up the pins for the red and green LEDs and also the buzzers. So lastly, the servo motor's initial position is set to 0 degrees, ensuring that the dustbin is stuck in the closed position. So let's look into void loops. These are main loops for the function. So in the void loop, the loop starts by calling two crucial functions, which is this function to measure the distance to the garbage using the ultrasonic sensors, and the motion dig function to detect the motion using the PIR sensor. Then I've used the map functions to convert the measure distance into the percentage value representing the garbage level within the dustbin. So next, a conditional statement is entered to handle different scenarios. So the difference between the start time, the ST, and the current time, millis, is less than 100 milliseconds. It means a recent event is occurred, likely to open the dustbin cover. Yeah. So in this case, the LCD display is updated to indicate the cover is open, and the servo motor is moved to 90 degrees to signify the open position and set the system state here, 90 degrees. So otherwise, if the garbage level exceeds 99%, the full level message will be displayed on the LCDs and activate the red LEDs while deactivate the green LEDs. So if the garbage level is below the threshold, the system activate the green LED and display the current garbage level percentage on the LCD screen. You can see here. So the the state of the system will be adjust and provide visual and auditory feedback as necessary. So finally, the delay of 4000 milliseconds is introduced to control the looping timing to ensure that the system operates smoothly. So next is this function. It is responsible for measuring the distance to the garbage using the ultrasonic sensors. It begins by sending a short low pulse to the trip pin to ensure a clean start, followed by a high pulse for 10 microseconds to trigger the ultrasonic sensor. So after a brief pause, it measures the duration of the echo pulse using the pulse in function. When the echo pin receive the reflected pulse. So by leveraging the speed of sound, the function calculates the distance to the object and update the distance variables accordingly. So providing the real time on the garbage level within the dustbin. So on the other hand, the motion dig sensor, the motion dig function is for detect motion using the analog sensors that connected to pin A0. So it reads the analog value from the motion sensor and compare it to the threshold greater than 10,000. So if the sensor value exceeds the threshold, it indicates the significant motion detection. So the functions check the current status. So states variable. So if states is not true, it updates the start time (t) with the current time, marking the event of motion detection. But otherwise, if states is already true, indicate ongoing motion detection. The function activates a buzzer with a tone of 1000 Hz for 1000 milliseconds, providing audible feedback. So if no motions is detected, the function stops ongoing tones on the buzzer, as you can see here. So that's all for my codings. Thank you.